Gatling. I don't know, has anybody been at JFOL last year? Has anybody seen this talk at JFOL last year? I have some new stuff, but the theory is still the same. So let's meet your speaker. That's on the left. The guy in the middle, I think some of you know him. It's Bertjan. He also did a presentation at I think 2 meetups ago of this group. And we together we work at Jenkins, a small software company, and we were together hired by Malware, and that was the place in which we developed this idea and the solution. Bertjan has now gone on to another challenge, but I'm still there. So what I want to talk to you about today is basically performance testing, getting us to do performance testing. I will talk to you about how we integrate this into our development process, because that's the whole reason that we started to look at tooling and came up with using Gatling. And in the second part of the talk, I will introduce Gatling and show you how you can build your Gatling tests and how we automated this process to some extent. So, how it all started. Malware is a company that, well, we are a traditional publisher, if you can say it. We make stuff for education. So we have educational methods. We have online tooling to measure exercises and do your tests, and for teachers to actually see how their students are performing and planning and all that sort of stuff. And a couple of years ago, we transitioned all this software into a pretty radical stack at that time, based on, for example, Vertex, all in the Amazon cloud and heavily automated. And in the past 2 years, we made the transition into a DevOps organization. So we have all our teams are empowered to do their own ops, or continuous integration, continuous delivery, everything. So by a show of hands, who of you does continuous integration? Right. And who of you does your continuous integration with all your unit tests and integration tests after every build? Who of you do performance testing? And who of you do performance testing automated? Oh wow, that's an impressive percentage. Most often I only get like 2 hands at this point, but there are many. Right, really good. Because when you do continuous integration and continuous delivery and everything, you have to have, well, at least I think you have to have everything under control. You have to know exactly what's happening with your software. Is it functioning correctly? But also, is it functioning fast enough? And this means that performance testing should be part of the process. You can't do it as an afterthought, which is, well, in traditional processes often was. So traditionally, it only happens several times a year. Probably at the major releases, and it is performed by a specialist. Well, this probably worked fine in the old waterfall traditional way of software development, but it's far from ideal, because often when it only happens several times a year, it means that the code changes that actually led to performance increase or degradation were made a long time ago. There are many changes which are incorporated into the software when you perform the test, and then you see it performs worse than it did before, and what caused this. So you have to look back into all these code changes and try to dig up from your memory what did we do and what might have affected this. And then all you know is how the software performs at that moment. Right? That's the only thing you know. You know how it performs at that moment. The minute you make another code change, you cannot be sure that the software performs the same as before. Well, okay. Some changes you can. I mean, changing a simple word in a string will probably not affect any performance, but as soon as you make any algorithm changes or anything bigger, there is a risk of performance degradation. And when should we test and when shouldn't we test? So who's to judge when we require a performance test after a change? So traditionally, waterfall. We design, we write code, we test code. Testing our code probably is done by unit tests and integration tests. I mean, we matured a lot in the last year, so now I think when I ask here who does unit tests and integration tests, I think everyone will raise their hand. A couple of years ago, that was different. So we have that part under control. We matured that part, and when performing these tests, we have these results, and then we make more code changes, and then it's a whole process. And then at a certain point, we think, well, now the code is ready to go to production, and then we think, well, now we have to see if it performs, and we schedule a performance test. And after that, we can release it. So this is, in this traditional process, this only doing several performance tests will probably work. It's not ideal, but it'll work. Now when you look at continuous delivery approach, where you design, you write code, you test code, and then you release as fast as possible because you want to have the feedback as soon as possible. Then it's a cyclical process, and where does performance testing fit in? When do you do it? So it should become part of the testing phase of your code. Not when other people make code changes, but after a single code change, single code change, that's the most practical. You want to see what the effect is at the performance of your application. So that's why we started looking into tooling that could help us perform these tests. Who of you do performance tests personally? Who of you use specialists to do performance testing? So, for me as a developer, I like to write code. I think it's cool. I do not like testing very much, I'll be honest with you. So writing unit tests and integration tests, well, like I said, I've matured enough to know that it is good for the quality of my code and to ensure that my code does what it is supposed to do, and I do not get cold at 10 p.m. that the software is not working anymore. So I write these unit tests and integration tests, and I do this, and the tooling for this has matured quite a lot, right? Unit testing in JUnit, integration tests using tools like Cucumber, Fitness, or there are several tools that you can use for this, are very well suited to writing, for a programmer to write your tests and to do this without much effort. For performance testing, I was used to using tools like Apache JMeter, for example, which has like this graphical user interface, and I had to click, and it was a lot of handwork involved, and well, I do not like to do that sort of stuff. So we wanted to have a tool that could be supported at the same level as unit tests and integration tests by developers. So continuous delivery for us means that the code always has to be production ready. We often joke that what we would actually like to achieve is that we have near the coffee station, we have this big red button, right? And anybody can hit the big red button, and any of our projects, no matter which one, will be put into production, the latest version, at that moment. If we can achieve that and be certain that it works, well, then we have continuous delivery nailed down. Then we have a situation in which we have everything under control, and we know that what we do is right. So code always needs to be production ready. We want the short feedback cycles, and we want to be self-supporting teams. And this is another important part, because when you do like Scrum, right? You do iterations of, for example, 2 weeks. 2 weeks are pretty standard. You might do 3-4 weeks, but in 2 weeks, you want to develop your software, test it, and put it into production as soon as possible. Then you cannot, or you must minimize external dependencies. You do not want to wait for the availability of a performance tester from somewhere that you have to hire performance. So you want to do this within the team. So, like I said, always under control. In fact, we want to see them as soon as possible, and we want no external specialists. That's not to say that external specialists are no longer needed. I mean, having a tool to do performance testing does not mean that you have the skill to write a proper performance test, right? And thinking about scenarios and how you build the load are actually things that, well, you need some knowledge for building really proper tests. So there is still, I think, a need for external specialists to support this, but it's no longer required that we have like several performance tests per year that we hire external specialists to do tests for us. We can now, for example, say, well, we want one performance test a year, which is performed by external specialists, which actually sets a benchmark for our software. And based on that benchmark, we can further during our development cycle see if we have degradation or an increase in performance, to see what the effect of our code is. And we know that because we have this baseline, and we know that at that baseline we can support the amount of users that we have in production, that any increase in performance is always good, and degradation we can assess if it will be a problem or not. So there's still some need for external specialists, but less. So we want this to have the same level of support as our unit test and integration test. It must integrate totally in our continuous integration solution. Zero downtime deployments are key for continuous development, and we have to have this performed by the development team itself. Looking at the process of performance testing, and now I'm actually going into the world of performance testers, so this is a bit of a slippery slope for me because I'm a developer. But when you abstract it enough, then you have these phases, right? You design your scenarios. For example, in our software, a student performs a set of exercises, submits them, and gets a grade. And, well, the teacher actually looks at the reports and sees that the student has made this test and all that sort of stuff. So those are the scenarios. Then you record it. Often you have to perform these scenarios yourself in the browser, record all the requests that are performed, and then you have the basic test, and then you have to do a step in which you can actually use this recording over and over again for a set of users. Because often there's certain logic involved in the front end of your application, and for example, you have to use different users during your test. You have to sign cross-site test forgery tokens with every request. Those are the things that you typically have to change after your recording in your test in order to make it usable for a load test. Then you can execute the test, and afterwards you have a report which you interpret to see what the performance of your application is. Now there are two types of scenarios, roughly. You have the scenarios that will test your core functionality, which are basically a generic test, which you shouldn't have to change a lot, because they have a broad enough scope or abstract enough scope. And then you have like specialized tests that you use to test specific features, but these are often really tied into the functionality itself. So whenever you make a minor change, you will probably have to change these specialized tests as well. While the generic tests, right, like the basic clicking through your application, well, those things change over time as well, but not at all. And the types of scenarios that I'm talking about in this presentation are mostly the top ones, the generic tests. So, in order to have developers like myself do this performance testing, we need tool support, because otherwise we just won't do it. And that's where Gatling comes in. And Gatling is a load testing tool, which is based on Scala, Netty, and Akka. and well, Scala is just a language. But Netty and Akka are actually important in that sense that it enables Gatling to put quite a lot of load on the system without using many resources itself. Because it's all asynchronous, active-based I/O, and it works, and therefore it's pretty lightweight. The Scala is actually, well, sometimes quite a nuisance, but it also helps because it makes the DSL that Gatling uses in order to write tests actually pretty readable. So that's nice. Alternative tools, I just mentioned JMeter, another tool that we see that is used in our systems, NeoLoad. Well, there are many more. But most often these tools are focused on offering a graphical user interface to a tester that can graphically alter the test and do all sorts of wizardry stuff. And as a programmer, I like to program and do this stuff command line, right? And that's where most of these tools actually do not have any support at all. With JMeter you probably could, but then you would have to hack away in huge XML files, which are pretty unreadable, and without any tool support. So, first part, theory part. Any questions on my my process? Do you agree?
Well, I have a question on the process. Do we mainly test HTTP REST calls, or also more on unit level?
No, it's more those are the REST HTTP calls. Yeah. Right. It's a broad, going through the application, resulting in several backend calls, and those calls are recorded and replayed.
But could you also use that on the unit testing level?
Yes. Yes. Yeah. You have the ability to make this as fine-grained as you want, and that's actually one of the benefits of having this opportunity to program it, because you can well you can use it in any way you want it, right? You do not need to record it and then visualize it. You can actually well just build your own suite, for example, of tests, and well, you can do all sorts of stuff.
So you run the tests in your pipeline or in an IPO?
Yeah.
That you run a bit longer?
Yeah, right. Yeah. This is exactly what we would like to have this part of our pipeline, right? Every code change results in a performance test, results in a report, results in something like this is better, this is worse. And then there's the issue of the long running of tests. This depends on the length of the scenarios, of course, but I can imagine our applications are not actually that big, but there are many systems that are, and in which it is not feasible to have a performance test running 20 minutes every build. So what we currently do, and that's mostly because we run these tests on our testing environment, and on this testing environment is also used by our test users during the day, and we do not want to have them affect our test results, and we do not want to have the performance test affect their experience of the application. So what we do is we run it twice a day. Every morning, at about 7:30, we run these tests, and every afternoon at 6:30, just before we destroy all our test environments, we run these tests. And then you have like an overview of what was the performance in the morning and what's the performance at the end of the day. And then you have only one day of changes to go through if you have anything. But it's one of the things that we would actually like to automate further. For example, by actually having a pipeline build spin up separate machines to do the testing on. We are pretty close to being able to do that. We have a pretty advanced stack in Amazon, but this is something that we haven't had the time yet to, but it would be really nice. So, looking at Gatling. Oh, sorry. Yeah.
Okay. Could you elaborate on a hard file and
Yeah, right. I will. Looking at Gatling, we have several core concepts in a Gatling test. And for example, with the Gatling DSL, which is a developer-friendly way of defining tests, the Scala code that I just mentioned. We have a scenario, which is the user logging in and going through the application in a certain usage scenario. And this is in Gatling, this scenario consists of HTTP requests. Right, so we do not test our front end with this tool. We test the back-end calls that are being made. You can use features, which are tools to fill request parameters. Right, you can provide files with usernames. You can provide all sorts of stuff from files or databases or whatever you want. Again, because this is Scala code, you can tie in everything you want. Right? You can just build your whole program around it. So this is really powerful. And then there's the recorder. And this is the tool that can record the HTTP request. The other option that it has is take a HAR file and convert it to Gatling DSL. And a HAR file is a HTTP archive. And I will show you when I demo the stuff what it means. It's actually what we use in our situation. So first demo, Gatling itself. All right, so
Make it screen bigger?
yeah, I will make it bigger. What we start with is building our Gatling simulation. And the Gatling simulation is actually just a Scala class. That is readable, right? Okay. So, throw away the banner. This is a Gatling simulation. It's a Scala class which extends from the Scala of the Gatling simulation. So this is actually in pre-dev. I import all. I actually know that I also have to use the HTTP pre-dev. So now I have my Scala class, and then we need to specify what type of protocol Gatling has to use, because you can use it to do HTTP requests, but you can also have your own custom protocols to perform. It also has file system protocols, for example.
But I have a question. I heard that Gatling was using UDP in the background for the simulations.
Okay, so now you're just one step apart from me.
Okay, sorry.
Because I actually don't know. I find it, I don't think it actually will use UDP because normally HTTP traffic goes over TCP, and because you need the acknowledgements. And
Okay, never mind.
but I can imagine that when you build your own protocol, or your own protocol driver, you will have the control to do that. Yeah, I can imagine it would be true. Okay, so my first simulation, what I would like to do is simply perform a Google search. So what I do is I will perform my test on the base URL, and the base URL is the Google website. And then I will also tell Google that we have a custom user agent at work, the Gatling of So now I've specified my protocol, and this will tell Gatling to use the HTTP stuff for the request, the scenario that it will perform. Now the other thing that we build is a scenario. And now I actually need my cheat sheet, because I do not know this by heart. Right, so what we start off with is the name of the scenario, and this is my first implementation. And now that we have the scenario, we can define the steps that the scenario uses. And these are called executions. So every step that a Gatling test does is called an execution. And in our case, we will be using HTTP requests. And we give them a name. So we start with requesting the Google search page. And when this, or this is a GET request to the Google website, and a GET request to the root. So this will tell Gatling to do this HTTP GET request. And after we get the result, I want to check that the status that I get returned is 200, HTTP 200. So now I have a scenario which consists of one step, a request to the Google start page, and after the request is returned, the response returned, we will have an assertion that the status that the response has is 200. So now that we have this test, we can set it up. And what we do is we, Gatling has a setup function, and then you take the scenario and you say that I want to inject a certain amount of users to perform this test. So there are the way to build up your users. There are different approaches. For example, you can ramp up users, right? You can say I want 1,000 users which are ramped up over 10 minutes or whatever, or you can say I want a continuous load of 2,000 users always, because your scenario actually has a time that it runs, and then the user is finished. So telling Gatling to have, for example, a test running for an hour with 2,000 users will result in Gatling starting new scenarios once the first ones are finishing. So there are many different ways to build up your users. I will ramp up my users, and I will start with a staggering amount of one user, and I will ramp it up over 10 seconds, which is actually it's nothing, it's only one user. So now this second comes from a Scala library. Right. So I define my scenario, I define the setup and how I want to inject my my users, and now I can run this this scenario.
The HTTP protocol you define, how you choose. You just defined it. I don't see you.
Right. This won't work because you're actually correct. I made a mistake. Thank you for telling me. Because I will need to define which protocols is. So, exactly. Now you tell it that the setup will use the HTTP protocol. So you have several ways of running Gatling. You can run Gatling command line with the Gatling command itself. We use the Gatling native plugin to run our scenarios. So I can now tell it to Gatling Maven execute, and we'll have to wait a bit for it to resolve some dependencies. Now starts the simulation that it finds. And it performs our request. And now we see that it gives us some information over the test that was performed, and it tells us that there is a report at a certain location. So this was basically just requesting the start page. This is nothing fancy. So going back to our test, we can expand our scenario. What we can do, for example, is at a pause time. Right? Often your users are not just lazily clicking away in your application. In our case, for example, a student will or most students will actually think before answering a question. So then you can put in some waiting time, some pause times. For our way of testing during our process, and we actually create a benchmark, and then we want to have our situation as similar as possible every iteration of the test. We make these pause times a default value, right? So when you record it, the recording will actually save the pause time that you actually use during creating your scenario. And we tell Gatling, we have a command to tell Gatling that he always uses like 1 second pause time between each request that he does. And this enables us to, because we re-record our tests every now and then, to use the same wait times every time that we do it. So now I have a pause, and then I will do another execution. And then I will do another HTTP request. And this will perform search. And this is a GET request to the search with the query parameter Q. Yeah. Right, so I tend to know the GUI API at this point. So this is a request that will make Google search perform the search for us. And then I want to do a check. And I can actually skip the check that the status is 200, because that's the default check that Gatling performs after each request. But I can do other types of checks as well. And the one I want to use here is the regex check. And this is what this allows us to actually check the body of the response. So what happens when I we go to Google.nl, and then I will do search Gatling. What it does is it changes the page title at the top. So I want to know that the search is actually performed. And what I do is I will check for the presence of this specific title. So now after this command is executed, we'll check that that it will actually have performed or at least Google sends us page back into which the title tag is present with the Gatling terminal. So now I've changed my scenario, and now we'll also make it more fun for Google. So now we use 100 users. Then we'll execute again. And we always have this wait time before, because it actually has to compile the Scala code that we just wrote in Python Scala, not very fast. So now you actually see this progress bar, right, progressing, and we see how many are still waiting or active and are done. Well, now they're all done, and we see that most of our response times are below 800 milliseconds, so one above 1200. 12 per 40. You can see in the table there. So now this actually gives us some more representative figures. Now let's make it really interesting for Google, and we will wrap up 1,000 users over 10 seconds. And we'll execute it again. And now our scenario will also run a bit longer, so we have to wait for it to finish. But still going pretty strong. Fast enough, right?
They are on vacation too.
Sorry?
They are on vacation too, mate.
Yeah, right. So let's see if it will continue to run. Or if you can break Google.
Not blocker.
Yeah.
So we can block. Yeah. We blocked two Jenkins.
How many people?
block your IP block, so then a lot of people
Actually, this happens. So now
No
we get an error back, and we can actually see what what happens here. Because now, when I go to the Google page, all's fine. Then when I search, and Google has noticed that it might be a bit strange for someone to request this many times the same search potentially with a CAPTCHA. So everyone using the same network as me will now have to type a CAPTCHA every time they do the search. So I hope everyone is cool. So, but this shows that I mean, Google is not we did not break Google, but we put enough load on Google to actually have them take measures against it, and that's only from my machine. So with this Gatling tool, you can actually perform pretty powerful stuff. You can do many requests, and with this is a MacBook which probably has a lot of processing power, but you do not need a lot to perform this. So
you can also verify response times.
Verify.
You asserted that you got 200.
Yeah, right.
But you can also.
Yeah, what you can do is you can actually those are checks, and then you have a set of assertions that you can add, which are mainly due to the sets that you see here. So what you can actually say is that you want zero or all of your requests to be in the lower response times, and you can actually say that you want a maximum of X responses in your that percentile. So you can actually pretty fine-grained have fine-grained control over the failure and success assertions that you can do in Gatling. And you can use these assertions in Gatling to actually you can let Gatling result into this HTML report, which is really nice to read for a user. But you can also have it write out in the JUnit format, and this enables you to have tools like, for example, Jenkins automatically fail a build based on the results of your Gatling test. So this is really powerful stuff. So this is writing using your code, and so you can build your whole test suite this way. But more often you'll find that you use the recorder to record the scenario and then change it, which is the thing that we do as well. We do this by hand at the moment. We're looking into automating this as well. So, for example, using a tool like Protractor to define the whole path through the application and then have the HAR file exported from the browser. We do not have this working yet because there are still issues. So we're currently doing this by hand. And re-recording this scenario is actually important because performance changes can not only happen because you make changes in the back-end code, but they can also happen because you make changes in the front-end code. So you might actually, for example, we use an AngularJS front-end, and you have this concept called watchers, and every time a watcher is fired, then you have to do something. And changing such a thing is quite brittle because you cannot always anticipate the effects that such a change will have. So, for example, we had one incident in which we actually had a production issue because of the event, because of the front-end change that resulted in. Alright, it's still there. I think we'll come back. I think Google's getting back at me now, I think.
a huge load back on
Turn. Maybe that's
back.
Ah, okay.
Back.
Right.
It
Ready.
seems like my chef wasn't
Thank you very much. So, you will not not see this effect of these front-end changes if you leave your scenario as it is. Because the effect of the front-end change actually results in a different pattern of your back-end calls. And is that fragile?
I can keep
I
like this.
keep like that, yeah, right.
You can bring the table a bit closer.
Yeah. No, it isn't an issue with
Straight,
the
okay. Okay. Ah, please. Right. Okay. I want that. I want this.
I'm going to be here for the...
Stand there,
So,
Please hold on.
I'm making a test.
Do you need anything, a drink, or?
Thank you.
Right on.
3, 2, 1.
So, like I said, so you can build up your own test suite program in Gatling, which is pretty cool. But in order to actually also capture the front-end effects of back-end calls, we use this the recorder. So then you can use a browser, which you use to click through your application. From this browser, you can export a hard file. This is something that you can do from Google Chrome and from Firefox as well. So when you use the network, the developer tools of Google Chrome and the network tab, I will show you, it records all these requests and you can export it as a hard file. We then take this hard file and put it through the Gatling recorder, and we feed the recorder certain parameters. For example, filter out all requests to Google Analytics, filter out all requests to static resources, because we don't have them. And the result of that will be a file like the one I just wrote, a bit more obscure because it has to use certain assumptions and defaults in the scenario, but in the Gatling DSL. I didn't touch it right, so anyway, so
Maybe someone doesn't want you to go like you.
So after that, then we have the DSL, and then we have to make this operationalized step that I just told you. And so we have to make some custom changes to the DSL, for example, handling our cross-site cache-for-you tokens, some login stuff. We have to change this in the DSL, and what we ended up was actually using using a small Java program to basically just string replace certain stuff in the Scala file to make these changes. We can then feed this DSL onto Gatling, and it results into in reports. Okay, so now I will touch it again, so it will probably fail. Let's see. Okay, so now I have switch out presentation mode here. Yeah, there it is. I have a small web app here, which is actually built on Vertex. And what this basically what it does is it starts a web server on port 8080, and it will show us a form, and we can type in a number, and then it will generate all numbers from 0 to up to that number, and it will sort it in descending in a descending sort. So it's a really useful program, but it will show us the purpose of performance testing, because what we also have is the service. By the way, if you're interested in Vertex, there are great presentations in Vertex online. For example, by Bejan, there we go. So we have this sorting service, and we can actually tell this sorting service to use a certain algorithm for sorting this array. So now we have an algorithm that uses a bubble sort. I will try to fire it up. starting and it's running. So now my project application is running, and I can go to the 8080, and there's my really useful application. Now I will start the network example. Google Chrome, clear it. First, press again. So now it has recorded my first request, and now I will ask it to use 15,000 numbers. And it returns our sorted everything. So the application works. This is the request flow that's actually performed. And now we can export this as save as our content, which I will do. And I will close. So now what I have is I maintain my har files in my source tree, actually. And this is what a har file looks like. Right, so it's basically just a big JSON object with all your requests and responses. You see, for example, if I search count. So here you see the request that's performed when I perform the search, and you also see that the headers that came with it, or all sorts of stuff. Now we can convert this into a Gatling file by running the Gatling recorder, and we actually use the Scala run plugin to actually start the recorder. And what this does, well, I have some output here that says that it uses the explicit configuration that goes in, so we flag this, for example, requesting of JS files and all that sort of stuff. So that will not end up in our Gatling DSL file. So now I have in my test folder, Scala at my first simulation, which I ran earlier on Google, and I have this sorter app simulation, which is the text that is has just been generated. So this is what came out of the R file that I created and then converted to Gatling DSL. So you see some stuff with the protocol. It actually makes the maps of the headers that it sent with the original request in order to mimic this. And then the scenario. So it's a little less readable. For example, request 0, request 1 is not very descriptive. So what we do is when we run the custom Java program over it, we actually find this thing, so the get request or post request, whatever, and we put that in the name of the action that we do, because it will make the reports more readable. Okay, so now I have the test, and I have my application, and now I can do the Maven. Quick, let me have a reasonable amount of users. Let's see what's good amount. Let's say I will ramp up users, say 500 over 10 seconds. Okay. I can get it executed, and it will fire these requests at my server. So what you see is you also have this counter, right? Like okay and not okay, which are indications your requests are working, and if the services or the checks that you do are okay. Now it's running through application, and it's almost done, and when it's done, it will give us the link to the report.
Default generated.
Yeah.
That's it.
Yeah, right. And now I will make a change to my application. I will actually skip my selection sort. So now I've changed an algorithm, right? It's just well, it's actually just one line that I changed to my application. I will go back, please. I will restart my server. So I'm certain that it will use the So now this is running. And then I will execute my test again. So what you saw in the results of our previous test is that it was almost 50-50 with regards to the request being in the less than 800 milliseconds and being between 800 and 1200 milliseconds. So let's see if these results are different. Then we have to wait a bit. Still progressing. Right, so, and now we already know this is faster, because why else would I show it? But this report will actually show you how much faster it was. So now you see 1,000 requests which are below our lower threshold. We'll take this file as well. Okay, so now you have these reports, which looks kind of nifty, right? So this is something you can show to management because it has all these nice colors and everything, and you can understand. And it's good to look at. So now we have these, what I told you, right? It's almost 50-50. Well, actually, I said it was 50% in the medium group, but it's actually 50% above 1200 milliseconds. You can actually these thresholds can be configured. Actually can be configured during report generation. So these thresholds are not thresholds that you're using with your cooking simulation. These are thresholds that you can actually add on later. So we start with these nice bars, which gives us an indication, and then we have this table, and here you see this request 0 and request 1, which is why I told you that we change it, because it will make it a little bit better readable. This actually looks a little bit like the table that we saw on the command line, but then horizontal instead of vertical. And now we also have these graphs, right, which will show you the build-up of the responses in regards to the amount of users that are, or the amount of requests that are performed. So these reports give you a pretty decent insight into what's happening during your performance test. Now we can compare it to the virtual, right? Looks a bit better. Everything is green. This is good. Green is good. And now when we look at the active users bit, for example, in the previous, the other report, we saw that it was right. It's not in the middle. It's going to the left. So we have we see that the first part of the scenario is actually it takes less time than the second part of the simulation.
But why?
Because the simulation is two requests. The first request is to the page itself, which is just returning a string. Right? No problem there. Which you can also see here when you look at the request 0, you see that the minimum response time is actually 0 milliseconds, and the maximum response time is 17 milliseconds. So that's nothing compared to the other request, in which the max is 14 seconds.
Well, I just mean, can you also make the simulation of the users more similar? But now it's not really comparable. It's less comparable.
No, it's actually comparable because both simulations are run with 500 users that build up over 10 seconds. The only thing you see here is the effect that the performance of the application has on the stuff. And the other graphs are there as well. So this, what this actually gives you is a pretty decent overview of what is happening, but you use this to well, determine where your problems are, right? So for example, based on this table, I can tell that my optimizations, if they're required, have to be in the in that request and not in the first one. But that's probably something that you're already doing. So these are the reports that come out of it. Let's go back to my presentation and finish up. So, this reports, this is what you already saw on and this is a report that we have in Jenkins. Right? We have a Jenkins plugin, and this will log the mean response, and then you can see this trend. Right? So we set a baseline at a certain point, and then we see that every test will result in a variation. So here we made a big performance improvement, and you can directly see it in Jenkins. So this makes it, and you can do this locally as well. So you can run these tests locally as well. So this makes it really easy to, for example, use it for performance optimization, because you can just automatically run your test after you make a change and actually directly see the effects. So using the approach that I showed you, what we can do is see how your code changes affect your performance, and we have this feedback on the performance in a short amount of time. But what we cannot see is how much load the application can endure in production. Because we do this on environments that are not similar to production, and we use our own broadly defined scenarios and not exact defined scenarios of our users. We actually, like I told you, we have a standard think time that we use between every request, which is not a representative scenario of production. So using this, you cannot actually see which loads you can endure. But what you can do is perform such a test on your production environment, which is representative, and then see how it stacks up to your test that is run on your test environment, which is prepared in a way and then you have your baseline. And then you know that every small variation in performance on that baseline will have a large effect in your production environment. So what have we done with this so far? We have prevented issues in production. We have used it to do performance fixing and database tuning, fixing memory leaks. Actually, by putting load on the system with Gatling, we could trigger the memory leak really easy. So that was not even about how fast the response was, but it was putting a load on the system in order to have reduce the amount of memory that we needed.
Can I ask you something?
Yeah, sure.
How did you see the memory leak? Do you have some memory dump or something, or is something that?
Well, how do you see the memory leak? You see the memory leak because Java just throws out of memory errors at a certain point in time, and then in order to analyze it, we instructed the JVM to dump its heap on out of memory, and then based on this heap dump, we can analyze it with tools. You can see what's actually in memory at the moment. We discovered that the asynchronous Mongo driver did not release its results, so it was a bug in the Mongo driver. We created a fix for it, a patch, and we could immediately test the patch using this using the usual load by Gatling.
Do you get the heap dump from Gatling?
No, that's actually on the machine.
Yeah.
We did some changes to the machine to dump the heap and then retrieve it. So in this case, Gatling was not a tool to tell us that we had a memory leak or to analyze it, but it was a tool that enabled us to put I think 10,000 users on our system during half an hour in order to make it fill up and die on us. So what we want to do is, now that we are here at this point, we want to automate the reporting process, because this is still done manually. So now our tester, every couple of days, re-reports the scenario. And we want to automate this, for example, by using or reusing the functional test scenarios that we already have. So we have a pretty big functional test scenario suite in Fitness. And if we can record these requests, then we can reuse them. We do not have to write specific scenarios. So we're looking into that. And we want to eliminate the custom code change, and we're pretty far with that. We still need 2 or 3 line changes in the generated file, but well, that's manageable. So, takeaways. Performance testing should be a first-class system, right? You have to make it part of your development process in order to have control of the performance of your application. Your front-end changes can impact the performance of your application, the back-end performance. Gatling is an awesome tool. And the approach that I shared, it monitors the performance trend. It does not determine the maximum load your production environment can endure. To GitHub links, I will tweet the link to my slides as well, so you don't have to write it down. In my repository, there is the demo application that I showed you, including the Maven setup, so you can pull that and see for yourself. In Bertrand's repository, there's a Gatling C, which is basically just a project skeleton, which you can do to start using Gatling in your own project. Just see how you set it up. Well, that was my my talk. Are there any questions left?
Yeah.
So I think I can do 1 or 2, maybe.
I have a question. Can you also replace your functional test by using Gatling? I'm wondering that.
No, I wouldn't do that. I think Gatling DSL is suited at, you write it as HTTP request, but you want your functional test to be as close to the functional lingo as possible. So there are tools like Cucumber and Fitness are way better suited for that.
But we also mostly testing, for example, the REST APIs.
Yeah, right.
Then you could not write those tests with Fitness, but only Gatling.
Yeah, that's possible, yeah. Right. I don't think I would advise it, but yeah. You could also use, when you want to test your REST endpoints, you can use just basic JUnit test. Okay, so 1 more.
What would be the benefit of recording as opposed to, for example, replaying data from production yesterday?
Well, actually, replaying your scenarios from production would probably give you better, a more representative scenario. One thing that is against it is that often you want to you have changes in your code, right? So do your production path still work in your new code? That's the question. Re-recording will use the application as it is in the stage where it is.
Once a week, right? It will only be recording that once a week or so.
Well, we are recording every 2-3 days, right? But we are recording not on production. We are recording on the testing system, which includes all our changes. So that's one thing that is difficult when using your production data. Is when there is a difference between your production endpoints and your test endpoints, which you make code changes. But it will give you a more representative scenario. Way more. Okay, so my time is up. I'm already way overdue.
The next time we'll bring some confetti.